Hey everyone, welcome. Okay, let's dive right into this. If you're looking to master back-end web development, you absolutely need a solid foundation. In this explainer, our goal is to completely demystify PHP fundamentals by taking what I like to call the builder's journey approach. We're going to treat coding just like building a house, starting from the tools and raw materials, all the way up to the architecture and final inspections. Here's the roadmap for today's explainer. We'll start by meeting our web engine, PHP, and setting up our local workbench. From there, we'll gather our raw materials with variables, build the architecture using control structures, plug in our power tools, functions, and finally inspect the house with some debugging. Let's tackle this step by step. Phase 1. Meet PHP, the web engine. Let's look at where this tool came from and why it's so popular before we start swinging hammers. So I want you to think about this for a second. When you submit a login form, or you load a page that pulls up your specific user profile from a database, what's actually powering that dynamic web experience? What is doing all that heavy lifting behind the scenes? Well, the answer for a massive portion of the entire internet is PHP. Originally built by Rasmus Lerdorf way back in 1994, it started as a simple set of personal home page tools. Today, it stands for PHP Hypertext Preprocessor. As an open-source server-side language, all the heavy lifting happens entirely on the server. It checks the databases, processes the forms, and then simply hands plain seamless HTML right back to the user's browser. Now, when you stack PHP up against other heavyweights, its unique strengths really start to shine. PHP uses a traditional request-response model with a super straightforward syntax, making it incredibly fast to learn and deploy. On the flip side, Python and Java offer highly structured environments, while Node.js operates on a non-blocking JavaScript event loop. We aren't picking favorites here, they all have their perfect use cases, but PHP's direct integration with HTML makes it uniquely tailored for traditional web development. All right, moving on to phase 2. Setup, or what I like to call the local workbench. You wouldn't build a house without a dedicated space, right? Well, you shouldn't write code without a safe local environment to test your projects before sharing them with the world. And building this workbench is actually remarkably simple. You just install a bundled package like XAMPP or LAMP, which conveniently groups your web server, database, and PHP all together. From there, you can tweak configuration files like your php.ini, drop your freshly created .php files into your htdocs folder, and fire them up in your browser via localhost. Super easy. Okay, so once your bench is ready, your very first piece of code will look something like this. Notice that opening bracket, the question mark, and PHP, followed by the closing question mark and bracket. Everything inside those tags is interpreted by the server as PHP. But here is the absolute golden rule. Look at that semicolon at the end. Every single statement in PHP must end with one. Forget it, and the server will absolutely throw a tantrum, leaving you hunting for a syntax error for the next hour. Moving right along to phase 3, raw materials, variables, and data. Now that we have our workbench, we need our raw materials. In coding, our raw materials are data, and the little boxes we use to store and categorize that data are called variables. PHP handles a few distinct types of data. We use strings for text, integers and floats for math, booleans for logic, arrays for lists, and null for intentional emptiness. Notice how we label these boxes? Variables always start with a $sign. A totally crucial point here is that variable names in PHP are completely case-sensitive, meaning a lowercase name variable is an entirely different box from an uppercase name variable. Function names, however, are not case-sensitive. Now, when placing these variable boxes around our digital house, we really have to consider scope. Variable scope is simply the context where a variable is accessible. A local variable, it lives only inside a specific function. A global variable lives outside. A static variable is pretty special. It actually retains its value even between different calls to a function. And hey, if you have a raw material that should never ever change, like the value of pi, you don't use a variable at all. You lock it in as a constant using the define function or the const keyword. Okay, we've got our materials. Time for phase 4, architecture, which is all about control structures. This is where we dictate the logic and flow of our application. It's how our code makes dynamic decisions. Think of conditional statements, like if-else, as literal forks in the road. They read almost like plain English. If variable x is greater than 10, we execute the first block of code and output greater. If it isn't, we fall back to the else block and output less.
If you have a ton of different potential conditions, you might use a switch statement to keep things clean, but the underlying logic is always the same. If one condition is true, do this, otherwise, do that.
This decision-making logic naturally builds right into loops. Loops are a lifesaver because they save us from typing the same code out 100 times. A while loop runs as long as a condition remains true. A do-while loop is similar, but it guarantees it'll execute at least once. A for loop runs an exact, fixed number of times. And a for each loop, that's a specialized tool used specifically for iterating through all the items in an array. Oh, and if you ever need to bail out early, the break command stops a loop completely, while continue just skips ahead to the very next iteration.
Now we're getting to the really fun stuff. Phase 5, power tools, also known as functions.
In programming, functions allow us to group blocks of code together so we can reuse them over and over, keeping our scripts incredibly clean. Let's say we build a custom function called greet. Inside the parentheses, it accepts an argument, a variable called name. Inside the curly braces, it dynamically glues the word hello to whatever name was provided and returns it. So if we call our greet function and pass in Alice, the script returns hello Alice. It's a perfectly reusable machine. But hold on, think about this. What happens if the user forgets to type their name into a form and her function doesn't get an argument at all? How do you handle that missing data so your application doesn't just break? You use something called a default argument. When defining the function, you just write $name equals guest. That way, if absolutely no name is provided, the function smoothly falls back to saying hello guest. Brilliant, right? We are almost done building. That brings us to our final phase, inspecting the house, which means debugging. Look, all builders make mistakes. You drop a hammer, you forget a semicolon, it happens. Debugging is the critical process of inspecting our code and handling those inevitable errors gracefully. PHP generally categorizes mistakes into 4 main error types. Parse errors mean you messed up the syntax. Fatal errors are serious problems, like calling a function that doesn't exist, which immediately crashes the script. Warnings are non-fatal issues, like missing an included file, but the script keeps running. And notices are minor issues, like using an uninitialized variable. To actually see these errors while developing on your workbench, you can easily configure your script to display and report all of them. When things inevitably do go wrong, you have 3 absolute best friends for diagnostics. Use Echo when you just want to quickly spit out simple text. Use printart when you need to output the contents of an array in a human-readable way. But when you are truly stuck, use vardump. Think of vardump with an X-ray machine. It outputs highly detailed diagnostic information about a variable, including its precise data type and length. It's a lifesaver. And that brings us to the end of our foundational build. Now that you've got these concepts down, I want to leave you with a quick challenge. Can you go to your local workbench right now, declare variables for your name, age, and favorite color, and write a script that dynamically prints them into a formatted sentence? Go test it out. Now that you have the raw materials, the architecture, and the power tools, the only question left is what incredible digital house are you going to build first? Thanks for joining me on this explainer, and happy coding.